Hi everyone, it's Kamil, and today we are going to create a BinanceMock in Elixir. It took me a while to realize that most of the viewers of this course are not necessarily a cryptocurrency traders, so they don't have a Binance account, and I shouldn't expect them to create one. So this episode is dedicated to them and to people that kindly pointed this out in comments. I really appreciate that. And if you are new here, read the description below to get to the GitHub repository. Otherwise, enjoy and don't forget to like and subscribe. First, let's start with the current state. Both the leader and the trader are using Binance module to place buy and sell orders, retrieve them back, and get exchange info. Exchange info doesn't require a Binance account as it's publicly available URL, so we can call the Binance module from our function. The remaining ones require Binance account and some cash inside its wallet. We need to mock those inside our module. We will update the leader and the trader to fetch the Binance module name from the config. We will set up the config so it's pointing to BinanceMock. Regards the BinanceMock itself, it will have the same functions as the Binance module provides. It will store both buy and sell orders, and it will allow us to retrieve them. That will cover the functions, but Binance also streams back trade events for those orders as they get filled. That's why we need to broadcast fake events to PubSub so the trader will pick them up. When exactly should we broadcast those fake trade events? Well, the best thing that we can do is to subscribe to the trade events stream and try to broadcast them whenever the price would be matched. Let's look at an example. Let's say that the current price is here and we are placing a buy order a little bit below the current price down here. As the price will change, which we will know based on the streamed trade events, we can safely assume that when it will fall below the buy price, which is 29.3, we can broadcast the fake trade event filling the order and change the order status to filled. The same method can be applied to sell orders, but we will broadcast that fake trade event when the current price will go over the sell price. Again, this is the current price and we are placing the sell order above it here, and it gets filled at the moment when the price will go over that level. As usual, it will become much clearer as we will start to implement it, so let's start coding. We will start by creating a new supervised app called BinanceMock. The next step will be to update the BinanceMock module to be a gen server. We will utilize decimal module for comparing the prices, logger module to log, and inside the state we will hold the order books, one per symbol. It will also keep track of the symbols that we are already subscribed to, and it will need to have a consistent way of generating the IDs for the fake trade events. As I mentioned before, to retrieve exchange info, we can just call Binance function. For buy and sell limit orders, we will write a helper function as the logic is the same for both order sides. The order limit helper function will assure the quantity is a float value. I realize that we are sometimes giving it a string and Binance module is still happy with that. Next, we will generate a fake order based on symbol, quantity, price and size. Next, we will cast a message to the BinanceMock process to add the fake order. Lastly, we will respond with a tuple of OK atom and order response to be consistent with the Binance module. We can now move on to the implementation of the callback to add order to the list. It needs to do two things: subscribe to the trade events topic for the symbol from the order, as well as add the order to the correct order book. We will write both of those helper functions below. Starting with subscribe to topic, we need to make sure that the symbol is lowercase and check have we already subscribed to that topic. Otherwise, we can safely use PubSub module to subscribe to the trade events topic for this symbol. We can't forget to append the symbol to the list of subscriptions and return the updated list. Next, time for the add order function. First, we need to get order book for the symbol of the order. Each order book contains a list of buy orders, a list of sell orders, and a third list of historical orders. Depends on the side of the order, we will update either buy side or sell side list, remembering that both sides are sorted. We are sorting them so we can easily grab all orders that should be filled whenever trade event arrives. This will become clearer as we will write a handle callback for the trade events. Now we need to follow up and implement the functions that we referred to previously. Those are generate fake orders and convert order to order response. We will implement those now. Starting with the generate fake orders, it will take a symbol, quantity, price and side, and based on them it will return a Binance order. Here we are also calling the process with generate ID atom. It will return a unique ID from the BinanceMock process. This way we will be able to run tests using the BinanceMock and always get the same IDs. We can now focus on converting the order to the order response. Order struct contains almost all of the same fields that the order response has and additional ones. We can use struct function without exclamation mark to ignore all additional fields. The only field that has different name is transact time field, which is called time in the order struct. We can fix that separately. Last function to finish support for placing buy and sell orders is to add a callback that will iterate the fake order ID and return it. We can now move on to retrieving the orders. First, we need to add an interface function that will call our BinanceMock gen server. The callback itself is pretty straightforward. We need to get the order book for the past symbol. We don't know the order side. Is it a buy order or a sell? Or maybe it's a historical already filled order. We'll concat all three lists and try to find an order that will match the past symbol, time and order ID. Finally, we need to handle the incoming trade events. We need to implement a callback that will get the order book for the symbol from the trade event. Next, we will use the takeWhile function on the buy orders with the prices that are greater than the current price. We will update their statuses to filled. The same applies to the sell orders with prices less than the current price. We will also update their statuses to filled. We can concat both lists of filled orders, convert them to the trade events and broadcast them to the PubSub's trade events topic. We need to remember to remove the filled orders from the buy and sell list and put them into historical lists to be able to retrieve them later. Here we can clearly see the benefit of sorting the lists. We can use functions like takeWhile and drop instead of filter and reject. Inside the callback we refer to two new functions that we will implement now. Starting with the convert order to the event function, it will simply return a new trade event struct filled with data. An interesting thing to observe here is that again all values are predictable and will be exactly the same for the same input. This will become beneficial for backtesting over and over again and comparing the behavior between runs. Broadcasting trade event to the PubSub will be the last function that will finish the implementation of BinanceMock for now. It's important to lowercase the symbol as we want to be sure that we will match the topic name, which is case sensitive. In our implementation, we hardcoded the default keys for the order book map 3 times. We can do better and introduce the order book struct instead. I've recorded the video in this way to show an example when it's beneficial to create new structs. That finishes the BinanceMock implementation. Now we need to add it to the children list of the application so it starts automatically. We can now move on to the trader, where we will add a module attribute which points to the Binance client dictated by config. We need to replace all direct calls to the Binance module for calls to the Binance client attribute. We need to modify the leader in exactly the same way as we just modified the trader. As both the trader and the leader are relying on the config to tell them which Binance clients should they use, we will add it to the config. Just to be on the safe side, we will modify the mix EXS of the BinanceMock app to list all dEPs required for it to work. We can now see the BinanceMock in action. First we will start an IEX session and double check that the BinanceMock process is alive, as config already points out to it, so we can continue as previously by starting the streaming and trading on the symbol. The trader and the leader are using the BinanceMock and it looks like everything works as it would be a real exchange. As we can see, BinanceMock works pretty well, and we'll be utilizing it in the future for the backtesting purposes. If you like those episodes and you would like to support my channel, don't forget to leave the thumbs up and subscribe. Otherwise, thank you for watching.